13.7, dilations. There we go, it's finally catching up. Here's our vocab for this online lesson. So a dilation is a transformation in which a figure stretches or shrinks with respect to a fixed point. So stretches or shrinks would be other words that we could use for dilation. Remember to pause, get it all down, and then resume when you're ready. The center of dilation is what that fixed point is called. Okay, so the fixed point of the dilation is the center of the dilation. And the scale factor of something is the ratio of a side length of the image to the corresponding side length of the original image. So if it's the left side of one thing, how does that relate to the left side of the thing that was blown up or that was shrunk down? Okay, so let's do some practice here. So it says dilation. I'm going to zoom in one little nudge here. In this lesson, the origin of the coordinate plane is the center of a dilation. Okay, so it's telling you where the center is. Okay, and it has in the image segment, so that's a line segment symbol up above. It doesn't have arrows. If it was a line, it would be A, B with arrows on both ends. Okay, but this is line segment, and it's actually A prime, B prime, so it's telling you the image. So in that diagram, A prime, B prime is the image of segment AB after a dilation. Because A prime, B prime over AB is 2, the scale factor is what? The scale factor is 2. So what they're saying is if I multiplied these numbers by what number? 2, I get these numbers. And look, what was the length of this guy? 2. What's the length of that guy? 4. Okay? So it says you can describe a dilation with respect to the origin using this notation. What am I multiplying x and y by? K is the scale factor. Okay, so whatever you did to the x and y's, that's the scale factor. So in this problem, if I said, what's the scale factor? You would say 2, because 2 plus 2 is 4. Sorry, times 2 is 4. 2 times 2 is 4. 4 times 2 is 8. 2 times 2 is 4. So that's the scale factor. Okay, so let's kind of apply this to a problem. It says draw a quadrilateral with the vertices, and it lists them, and then find the coordinates of the vertices of the image after a dilation having a scale factor of 2, and then draw that image. So we're going to draw our original. I'm going to do it in pink. Okay, it's a quadrilateral. So -4, 1, and remember we want to label these. That's A, 1, 3, 1, -1, and -3, -1. And use a ruler if you can't draw a straight line so that it looks somewhat pretty good. All right, so there's my quadrilateral. Now I have a new guy, and he has been basically doubled in size almost here, right? Each of the coordinates have been doubled because the scale factor is 2. So what we have done now is we've multiplied each x and y by 2. So that would be -8, 2, 2, 6, 2, -2, and you need to be doing the math. Don't just copy down what I'm writing. -6, -2. Okay? So now we're going to draw the new guy. Make sure you're labeling them with the primes. And now for sure, I'm going to need a ruler, and you need one as well. Otherwise, we're not going to have straight lines there. Actually, I'm going to use the side of my protractor's not quite straight, so we are going to use a ruler. Okay, so this guy's been dilated. Think about what dilation means if you go to the eye doctor and they say they're going to dilate your pupils. What do they do to your pupils? They made them really, really big, right? The center of your eye, it got really, really big. They were dilated. So it took the exact same size and it made it bigger. also be smaller in instances. Okay, so you're going to do the checkpoint down here. There's triangle DEF. You're going to draw that guy, perform the scale factor, and you're going to lift the coordinates out just like this, and then draw the new guy as well. Pause the video and go ahead and do that. Okay, so your coordinate notation, you're showing that you multiplied x and y by 3 each. Here were the new points. My original is pink, and my new guy is green. So my new guy, again, was bigger than my original. All right, go check in with Mrs. Wyman if you're having questions. If not, let's go to the next page and take a look at that. This is when our scale factor is less than 1. What do you think is going to happen if we have a scale factor less than 1? That's exactly right. It's going to shrink. So we're going to draw PQR. I'm going to draw it in pink again. That's been the color I've been using for my original. So go ahead and do that. Make sure you're getting them in the right spot. That's pretty big, so that's going to be a ruler as well. And now take a look, once you've drawn this, at what's happening to the scale factor this time. It's less than 1. It's actually 0.5 or a half. So each one of these is getting multiplied by 0.5. I'm going to do this in green. So 0.5, or we could say we're taking half of it. Okay? So that's the way I'm going to write it. I like thinking of it as a half better than thinking of it as 0.5. So half of -8 is -4. Half of 4 is 2. So go ahead and do that for each one. Okay? And then you're going to draw the new guy. And should he be bigger or smaller? Absolutely, he should be smaller. Okay, and there's my new guy. Okay? The same thing happens when we're doing pictures, like taking photographs, right? Everything gets shrunk down, but it still has the same perspective. In example 3, we have to find scale factor for some computer graphics here. An artist uses a computer program to enlarge a design as shown. What is the scale factor of the dilation? So which one's the original if they're saying they're enlarging it? This guy's the original, there's my enlargement, okay? So what we need to do is we need to find the width of the original design and then the width of the image to help us get the scale factor. So the width of the original design is right here, and you can literally just count how many squares they go over. 1, 2, right? It's 2. Or we could say it went from 1 to 3 over there, right? So 3 minus 1 is 2 units. You can just count like I said. The width of the image is right here. How many is that? 1, 2, 3, 4, 5, 6. It's 6 units, or to show the math, it was 9 minus 3 to get to the 6. All right, so scale factor is what over what? It's image over original. And that's something you need to remember, image over original. So the image was 6, the original was 2, so the scale factor is 3. And then think about it, it's 3, that's a big number, so did my new guy get bigger? It sure did. Okay? All right, so let's look at the checkpoint 2. This time, they're not giving us a picture. They're just talking to us, and we have to find the scale factor that way. So we have a segment CD, and here are the endpoints of CD. Then we have a new guy, C prime, D prime. Here are its endpoints. And they're asking us to find the scale factor, okay? So what we need to do is we can say that C was 6, -9, and then it went to C prime, which is 2, -3. So can you see what I'm doing to get from 6 to 2 or -9 to -3? 6 to 2. What am I dividing by? I'm dividing by 3, but we can't say dividing, right? It's basically a third of it. You need to say, what are we multiplying it by? So we're multiplying it by 1/3. You could have looked at the changes in D to verify that this would work as well. So D went from -3, 1, to -1 and 1/3. A third of it, yep. A third of it, yep. So the scale factor is definitely a third. I'm dividing by 3. Dividing by 3 is the same as multiplying by 1/3. Okay, so those are the notes, and you're on to your next task. Good job.